to integrate that as much as possible within our tools, right? You can start with any of the modeling tools that you have here, our SIPE Architecture, which is a free architectural modeling program, or from the other brands that you see here, and implement it within our um, relevant SIPE tools and begin the work from there. Excuse me. And from there, you may be able to import the model and get what I think would be is what would be the most useful aspects of using SIPE would be getting automated specifications, cost estimation, automated drawings as well, schemes, diagrams, reports according to the code that you've selected. And we'll be taking a look at that later on. Don't worry. I think as well for this is our BIM Server Center. You'd be able to update a shared project in the cloud as well. So the way that our modeling works is that everything is federated. You can begin the work in any of the programs. You don't have to acquire all to just work on structural analysis or just to work on energy and efficiency, because I think it doesn't make sense, right? Because if you are as an plumbing engineer, or maybe as an HVAC engineer, or maybe as an energy consultant in this case, you'd maybe just engage in relevant programs to your work or to your projects, and you don't need all the rest of the tools that we have. And that is completely fine. And we recognize that workflow and project going to be more expensive, right? For you as the user and for your team. So we implement that alongside our philosophy as well. You can begin at any time. You can begin with the terrain, the architecture, the siting, the structural model, the slabs, the reinforced concrete model, the plumbing installations, electrical, HVAC, the architecture, and the bills of quantities. At any point, you may be able to use whatever program of SIPE best suits your needs. And I think what we provide our users is actual efficiency in terms of how they speed up their work. They have more time to do other business, they have time to do other projects, but still maintaining that accuracy that we as engineers really need for our projects to submit for approval, to submit to our clients, to submit to the government for their own documentation, right? And the way we do this is the automatic generation of technical reports. For example, what you're seeing here as our sample technical reports generated by various programs, right? We have the load summary. This is from our HVAC program. We have as well our ASHRAE document here, the reports for the ULS checks from our structural analysis programs, citing the code, the calculation that was used, and even how it was calculated and in the document and generated by the program automatically. Another useful thing I think would be the drawings as well. Not a lot of brands would be able to do this, but I think this is something that is very incredibly useful. Being able to just get automatically the drawings, the specifications of, for example, the steel connection design, as well, a plumbing installation as well. You'd be able to customize it according to your needs for your client and for whatever requirement you're gonna um, use it for. So in this case, the work of maybe a day can be generated by SAP in maybe like in a few minutes or even in an hour or so, depending on your project, of course. And another tool is getting the bills of quantities as well. Here, counting it automatically in the program. I think that is a really good way to measure efficiency, right? How you're able to do less work, but still do the same amount of work, right? For less time, essentially, is what I'm trying to say. And I think other than the technical features of SIPE, we also have our own commercial features. We try to also be engaged and make it different to be with the user. We try to assess what they need because not everyone, again, they don't need all of our tools. We have our perpetual floating licenses. It's scalable, modular, technical support with a centralized SIPE launcher through our SIPE menu, something similar to this if you're seeing it on the screen. It's our launcher for all things related to SIPE programs. If you are maybe familiar with video games, they have Steam. This is essentially similar. It is a launcher. You have your account here with your electronic license number, and the purchased programs are highlighted in a different color and are not grayed out. That is something that we have in our programs. And as I said before, the key benefits of choosing SIPE would be really it really depends on your needs, right? It doesn't mean that you need to acquire everything. You can boost your productivity with parametric modeling depending on um, the program or the type of project that you're using. Compliance with international standards so that we keep on updating every day, every patch. So with recognized analysis engines as well, full OpenBIM compatibility, and reliable results in automatic generation of documents. I think these are like really good benefits that you can have where as our users and all of our users believe in us. Well, aside from our professional licensing, we have also our campus licenses, our education licenses for all. Maybe there are teachers or professors or universities that are present with us today in the audience. You'll be able to talk about that later on. We provide as well our licensing for educational and research purposes. So that is something that can be arranged through our company as well. So in our 40 years in the industry, we have gathered a lot of and worked with a lot of clients. A lot of them, of course, are from Europe. In Spain, we're based, but hopefully our some of you maybe and some people from Indonesia and Asia will make it into our list very soon, hopefully. But I think that would be an end to a bit more of a theoretical introduction to who we are at SIPE. And I think now is the time that I will invite my colleague Martin to maybe talk more about the where of our presentation for today, of our workshop, which is actually opening the software, diving into what can be done using BIM technology and energy efficiency in our tools here at SIPE. Martin, you're there? Hello, Martin?
Hi, Paul. Yes, I am here. Thank you. I was changing actually my computer from one place to another to be more comfortable. Thank you so much, Paul. So we should get started, right? I would like to start with a presentation on the maybe less practical part, more maybe showing about the BIM workflows with our platform BIM Server Center, and maybe introducing a little bit about the programs, right? And in a second part of the presentation, I would like to actually use the programs in a really fast and brief way with actual simple projects so that our audience today are able to maybe see the programs working and what they may get out of them, what information, what output, what professional output we can expect. So actually, let's get started. I'm going to share screen. Have these warnings here about the Zoom meeting. Yes, okay. It's asking me about the languages. Mm-hmm. So I will start sharing the screen. 1 second, please. Okay, so here we are. As Paul explained it, this is the webpage of SIPE. This is the webpage of the company. If we scroll a bit downwards, we can see our solutions, a bunch of programs for the different areas of specializations that may take place in a construction project, right? So this is one thing. And then on the other hand, if we move to the BIM Server Center, this would be our platform for working in BIM, right? It is an option. our programs are good to go for working locally in a traditional way and so on. But actually, we have also the possibility of work with BIM, right? With the BIM, and for doing so, we have the BIM server.center. That's the name of the platform and also the address of the web environment of the platform, right? So just writing BIM server.center, you may reach there. It is free to use. It's unlimited storage capacity for the projects. So actually, it's a really interesting tool, right? I'm going to use a highlighting tool here and going back to the web page. So today we're going to focus specifically on the energy and acoustics, and I'm going to address the SIPE HVAC 2, the program for making HVAC projects. Why is it interesting to use these programs? Well, when we are talking about being sustainable when generating our projects, to achieve that, it is really important to have information as precise as possible and as professional as possible, basing in tested methodologies. Innovation is great, but innovation applied to tested codes, professional standards, and methodologies is better, right? And as we see, we have different tools for acoustic simulations. I'm going to switch off my camera and keep going with the screen. Okay. So in this list, we have, first of all, IFC Builder, which is a free BIM modeler, right? So I am going to use this program today, later on. This is a 2D work environment. It is a simple BIM modeler. The idea of this program is to be able to generate a 3D model, but we are based on an environment that works floor by floor, right? And why is it useful? There are many BIM modelers around, right? There's massive amount of BIM modelers. Even in SIPE, we have another one, which is called SIPE Architecture. I will talk about it right away. But there's also other BIM modelers, Revit, ArchiCAD, Allplan, you name it, right? So what does the IFC Builder has that it is special? Well, it's the only one that I know that it generates automatically a really important information for energy simulation and analysis, which is information on adjacencies and edges, right? Each time we model a building, we are modeling walls and slabs and so on, and they contain spaces, they contain rooms, right? So the fact that one space is in contact with another space or with the exterior, that relationship, okay, is this wall leading to the outer space, to the exterior, to the open environment, or is it just leading to another space that it's also maybe heated, right? So that information, maybe it's me lacking information, but I don't know any other modelers that generate that automatically, right? And it's vital for actually analyzing the performance of the buildings. So if one wall leads to the outside or to another inside conditioned space, it's a really massive difference. And we wouldn't be professional if we didn't take that into account, right? Same happened with the edges. When we model a building, we model walls, slabs. In the end of the day, we are containing rooms, spaces, or whatever kind of closed spaces, right? These 3D volumes, they almost always have edges, right? So again, do these edges lead to another, maybe to an upper floor with another space that's also heated or cooled? Or is it leading to the exterior? Is it a thermal break or not? And if so, what is the coefficient according to the kind of solution that we're using there? So all that information it is generated automatically by the IFC builder. We have that opportunity, right? So we model in 2D floor by floor. We'll show you in the second part of the presentation, right? And you're generating a 3D model that you may generate floor by floor. And when you generate that model already contains the information about what I just explained it. So by using this, we are saving steps if we are going to model with the aim of getting a professional energy analysis, right? There's another option, right? The other option is that we have a BIM model that comes from somewhere else. If what we have is 2Ds of a building, like DWGs or 2D plans of a building, you can simply import those 2D plans into the IFC builder and model our building there. And if it is a regular geometry building, if it's not a geometrically complex, and if it's suitable for modeling floor by floor, and if we just have the 2D, we can just go from 2D to BIM for free by using this tool, right? IFC Builder. And we are having the information of adjacencies and edges, right? But maybe we have other model that doesn't come from IFC Builder. It's not a problem. That's why this other program exists, OpenBIM Analytical Model. So if the BIM model we have, it comes from SAP architecture, if it comes from Revit, ArchiCAD, Allplan, you name it, as long as that tool has generated an IFC model, we simply need to introduce the model here and generate that information of adjacencies and edges, define what are the behavior of the surfaces there. We can do that with OpenBIM Analytical Model. So once we have a BIM model, a 3D of a building with a standard definition of that 3D and so on, we can start using our tools, let's say SciTherm loads for calculating thermal loads in an efficient way, introducing automation in that old school procedure about the radian time series method that basically we've, at least myself, I've performed many times by hand. And by this, I mean like 2D CAD and Excel, right? This thing we did on other 3 books and so on with the Ashra method. We now have it all together in a tidy place, SciTherm loads, and it automates and saves hours and hours, right? And also we have the SciTherm E+, which not only calculates the thermal loads and as the SciTherm loads, it gets you the thermal loads, and for doing so, it analyzes the passive behavior of the elements. In the SciTherm E+, we also introduce the active energy consumption of the building, apart from the passive behavior of the walls, the slabs, and so on. We also add there the systems that are consuming energy, and we have a complete definition of the behavior of the building, taking into account not only the behavior of the walls and so on and the windows, but also the systems that we include there. So we have different options. We may have 2D information, we may have a BIM model. So if we have the 2D information, we'd go for the IFC builder. And if we had another BIM model coming from somewhere else, we should go to OpenBIM Analytical Model, right? So I'm starting talking about the modeling. We also have another program that is the SciP architecture. That is also a free BIM modeler, right? If you just have 2Ds of a building, you can use these tools, which are professional tools that we have, simple ones, and that are free to use. And if the building is not a regular building or it's not suitable to model that in 2D, like floor by floor, if you have double heights, if you have complex roofing, or just a building that cannot be modeled floor by floor, then you could use SciP architecture and then go for the OpenBIM analytical model, right? So So far, we've presented what are the programs that we are going to address today. Once we have, for example, calculated the thermal loads, we could go further and move into the HVAC definition, right? The project of the HVAC of the building, and we have SIPE HVAC for that. We also will cover that. In SIPE, in our company, we generate tools for the actual engineering projects of a building. It's not just modeling, just fancy geometry, right? We do model, but the users are the actual professionals in charge of each of their disciplines, right? So for example, it is not unusual that our users just use one tool and not use the other. Maybe we have users that just use SIPE HVAC because they have the thermal loads calculations from somewhere else. So they wouldn't need to know about SIPE therm loads, or they wouldn't need to know about the BIM model. They just get the building and do the HVAC there, right? But maybe we have users that are the other way around. Maybe they have like the SIPE therm loads people. Maybe we have an engineering firm that they perform the calculations with SIPE therm loads and SIPE therm E plus, and they send this to an HVAC team that will actually generate that installation, make that design, right? So we have users that do the whole process. They just get the 2Ds, generate a BIM model, right? We also have users that only use BIM, right? They only model, and then they send this to the people of the SAPTherm loads. Or we have people that they don't use this, they just calculate with a spreadsheet and then use SAP right? So this is the reason that we have different programs for this kind of workflows, right? So far, I am explaining the programs that we have in a web page. I would like to highlight that when we access the programs here, just by clicking, we access the detailed information of those programs. So you may go to the download part, or you may go to the learning resources. And here in the learning resources, we have detailed information, videos, tutorials, and webinars. So actually, we can access the detailed information of any of our programs, and we have like a user manual with each of the things that you need to know how to do one by one. So it's a user manual, but it's online. All the possibilities of the software are described there, right? So a way to reach our programs is the web page. Another way to reach the programs is through BIM Server Center, specifically through the store.bimserver.center. If we access through the store.bimserver.center, again, we can browse for the programs. Let's say SIPE HVAC. There it is. And here we may see examples, right? These are real projects from our users worldwide. When they choose to share their projects, they have a free platform for doing so, maybe for marketing purposes, maybe for sharing just with their clients or collaborators without them having to have any license of SIPE HVAC, right? If you have a client or a collaborator in another city and you do want them to see your work, they don't have to own the program. They just have to access this platform and it's free to use, right? And again, important. So again, I will repeat, store.bimserver.center. Just browse for the program that we are going to talk about, for example. And you have all the information, the technical information of the programs there, right? We go deep there into the learning resources, and we have even a quick start guide with small videos, 5 minutes or 10 minutes videos there for each of the just get started, or detailed information again and again, right? So enough of this introduction about the programs that are going to use. Having professional tools allows to have professional output. What we reach or what we achieve by using BIM, software, innovation, automation is nothing more and nothing less that the same that we did by hand. And when I say by hand, I always mean kind of 2D CAD, spreadsheets, Excel, like kind of 3 books and a notebook, like paper, like for taking notes. I mean, that's what we can get is that, but just in less time, right? Or combine that with the programs and saves tons of hours. I always say this because it's nothing less than that, but nothing more than that. In the end of the day, we will have to achieve professional output, 2D plans to send to the authorities to get a license, reports, text reports to send to our clients or to an institution to certify whatever. And that is what our programs generate, right? Is we have the BIM output, but it's just that, it's just one possible output. In the end of the day, what our users look for is the actual like kind of professional output, right? We'll see when using the programs. So this is the BIM server.center. Before starting using the programs, I want to show what like visually we can do with BIM and how to use it. To just get registered, it's as easy as hitting register. There, it's email, name, password, and few basic data there. You get confirmation email to activate the account, and that's it, right? I'm accessing my own account, which is Martin.Rodriguez. That's myself. And here we have a first look on the BIM server.center platform, right? There's 2 areas. There's a public area, like kind of a social media style place where we can share, we can post, we can react or connect with other people and so on, if we choose so, right? So if we make our project public and decide to post what we've done, you can do so. Companies do this for marketing purposes. Students or freelancers or just small firms, they do this for getting a portfolio in a free and professional environment. And actually, this is consistent with Open BIM standards. So actually, it's a good place to move around. So this is again the public area. When we get into the BIM Service Center, we land that area, which is the activity part of it. But the place where we actually work is projects area here. I'm clicking there. And here we have our BIM projects. In the end of the day, we are speaking, to put it simple, about a cloud environment, which is free to use and unlimited storage capacity, but it's like a cloud where we may have projects of different buildings, for example, and within those projects, we may work collaboratively or on our own, but working from different disciplines, right? So, and we may work like with more people or not. I'm going to try to reach one example that's really visual to explain what we may do here. So this block of housing units, I wasn't the creator of that, right? Somebody else created that project. To create a project, by the way, is as easy as generating a new project. And then you can work on your own there. You have your place in the cloud to work on a building, or you can work with more people. You should invite them to do so, right? So somebody else generated this one and invited me. Then in this specific case, the idea of having a BIM workflow is the following. We will have the possibility of uploading a BIM model with the geometry of a building, the walls, the roofs, the slabs, the windows, the doors, the stairs, like the geometry of the actual building itself. And then you can use that to work over that and generate the professional projects, right? In this case, somebody else uploaded the architectural model of this building. It was generated with SIPE architecture, with that program specifically. And then in this case, I used our program SIPE Plumbing to generate the water supply and wastewater. And somebody else used our SIPE HVAC to generate the HVAC installation, right? And have different disciplines. Of course, we could have somebody else working in the structure, the reinforced concrete for that. So they would be using SIPECAD and so on. Actually, this is the way we see the different contributions. We can click them and we'll have the actual IFC model, which is the file with the 3D BIM model according to the IFC standard, right? We have different documents such as actual DWGs, like the 2D of that building floor by floor. So in each contribution, this one with the architectural model, that one with the water supply, we have the actual 3D, but we also have the possibility of having the BOQ there, 2D plans again, and so on. So we could watch the different contributions one by one or watch it all together here in the BIM Server Center. This is just my web browser, right? So I use the programs to make the models, to upload them into this project, but I can just see this from my smartphone, from a tablet, from any web browser. And to see, I don't need to actually have the licenses of the program. This is just a web browser, right? So in this case, let's go with this one. It might take a few seconds to load. And we will be seeing, for example, the geometry of the building plus the water drainage and water supply for that building, right? So we have that project. Let's wait maybe a few seconds more for this to get generated. And we may orbit around, watch the building, and then maybe hide the building to see through it, and then see the actual project for the water supply and water drainage. And this is not just fancy geometry. This is actual professional output. The pipes have been automatically sized. The hydraulic analysis has been performed. And this we're seeing is a result of that. So it's not like just fancy models. It is fancy models, but it's also like professional visibility of, I will even hide the building so that we can see that we are actually watching the ID of the BIM element, the type name of that, the fit tank, where has it been generated, this pipe, diameter, material, length, right? And this diameter is this because the hydraulic analysis says it is needed for the supply of this building, right? And according to the code that we've used, in this case, a UK standard, right? So this is completely professional output. Today, we are going to be talking about energy. So maybe we are more interested in the HVAC project that has been performed after all the analysis of the energy of a building. Why is it interesting to have tools for maybe calculating the thermal loads professionally? Well, to not oversize, not overconsume power, not heat the equipment, right? Have a neat use of it. So if we don't have precise definition and precise information, it is really unlikely that our HVAC, for example, will be sustainable. It should be like the size it needs to be, just to be within the codes, right? Within the professional codes, or common sense at least, and the criteria of the technician in charge. So in this case, this is the HVAC project of that same building. So advantages. First of all, we don't need to model the same building again and again. We don't need to be drawing the same CAD 8 times. Then if we calculated the thermal load, I am able to use that information and automatically size the equipment of the HVAC, and also being fast in the development of that project. And that's pretty much it. And again, this is not just fancy geometry. This is actually rededuct with the shape, the length, the quantities, properties, the material, the type naming, where which program does it come from, and according to the OpenBIM standard, right? This is not the OpenBIM standards are not from SIPE, from our company, or from anybody. It's just a global conventionality, right? The definition of formats and standards that we should all attach to, like, let's say PDF for text instead of owned programs by specific companies, or CSV or similar instead of just one owned format, right? So this, what we're seeing here is BIM server.center is what we may have as an output if we choose to work BIM. Let's go back into the project itself. The same way we're talking about HVAC, we could be talking about structures, and the fact that we can put all this together is really interesting because we also may prevent the clashes between structure and MEP, the geometrical situation of the elements of the building in 3D, so we can actually see or detect potential problems, right? So in this case, this is just a structure, but when we overlap structure and MEP, or MEP and HVAC, for example, right? We have really interesting possibilities there without having to wait until the last day where the guys in the works are putting the pipes together and find out that we're going to lose tens of thousands of dollars because we need to modify the project because it suddenly clashed or it wasn't possible to build, right? So this is why it is a good idea to use this kind of tools, right? BIM Server Center. So we have the BIM Server.center itself with its 3D viewer, with its downloads area, we can put all together there and so on. Or we can also use the BIM Server Center to access the store, right? And in the store, the same way that we use the web page of SIPE to check the information of the programs, or you can check the programs. I actually use this part of the BIM Server Center to reach the information in all the stores, in each of the programs, excuse me. So any questions so far? I am going to move into the use of software for the purpose of analyzing the behavior of the buildings from an energy point of view, right? So I'm just moving into that. I'm going to start using IFC Builder and SipeTherm loads, and IFC Builder, and then SipeTherm E+, and then I'm going back into the camera, right? Okay. So if there are no questions so far, of course you can do it in the end. I'm going to move into the use of the programs, right? What I'm going to do is I will open IFC Builder to explain you what it is about, how to use it. Then I'm going to use SipeTherm loads to use that geometry of the building in order to generate the calculation of thermal loads, for example. Why is this important? Because this way we can generate correctly sized HVAC, an efficient consumption of energy in that part of the building. And also we will have, along the way, we'll have relevant data about the elements of the building. We will see in the reports, when we calculate the thermal loads, we'll see why is this room needing this amount of power to get heated. Because the wall will be losing this amount of energy, the window will be losing that amount of energy, this equipment, the ASHRAE method will use that. And by knowing that is that we have the tools for improving our design, right? So this is not like magically automatically improving the design. This is like magically having good information for being able to make the decisions to improve our design, right? In the end of the day, I always say the same. For me, from my point of view, software for engineers or for architects, professional software should be like an airplane. It's great. It improves your ability. It allows you to move from one place to another fast. but it needs a human pilot. You cannot not have it. It's not an option. You need a human, which will be the responsible of the lives of the people in the aircraft, right? So even just even if it's only for having somebody in charge, somebody responsible, you'll have a human there. So that is what you or me or the technicians are, the pilot of that program. It's not you cannot know nothing and use a program. You need to know and use the program, and then you'll be able to just save hours and hours. And instead of doing it by hand, you'll be able to do it. Okay. Let's move on into the use of the programs, right? I'm going to use IFC Builder, Cyptherm Loads, and then Cyptherm ePlus, and maybe for finishing the use of SciPageVac, for you to know what is the concept in our modeling tools and the automation in the calculations for generating HVAC and so on, right? Hope it's interesting for you. I'm sharing the screen again and shutting off my camera again. 1 second, please. Okay, so now we are back in my screen, switching off my camera. Okay, so I'm moving into my desktop now. What I use to launch the Cyp programs is this small program here, the Cyp menu. It is just for not having all the programs like around the desktop. You could have them, but what I choose to do is to have the Cyp menu. Just double clicking there allows me to access all the programs in one same place, right? So again, you see the different disciplines here. Let's move into the IFC Builder. This is opening just a new IFC Builder file from scratch. And I'm going to perform the basic operations and then move into an example building so you can see what you can achieve there. On the other hand, I'm going to move into Cyp architecture in case you want to check that program out too. So we've opened IFC Builder. This is a look of a program when we are going to start, when we run the program and we're going to start using it. This is common. This format is pretty much the same in all the Cyp software. And we have, of course, file manager, examples that are there for training purposes, documents, and specifically, I would move into the web browser to have technical information there, right? So let's go with a new file from scratch. I'm going to use an empty job. The program asks you to define the levels. In the BIM world, let's put it that way, it is really important to have certain concepts into account. One of them is that we have to be tidy and professional in the definition of the levels, right? Each element in the project will be included within a level. So having the levels is important. It's not like just 3D random modeling. We have to be tidy in the organization of information. In this case, we have the basic ground floor and roof. We could add more. Let's say another floor 3 meters high, which is called floor 1, right? For example, we're going to delete it and go whatever way we want. The program asks me, are you going to use a template? This would be, are you going to use a CAD, DWG file, image, whatever, right? I could do so, or I could cancel and skip that part and or say no. Why? Because we can always do that from here. Actually, I'm going to make a small experiment. I will show you how to put 2D into our programs to go BIM, to go 3D, right? I'm clicking this command, then I'm clicking that thing over there. Then I'm clicking this again, and then this is my computer. This is Escritorio desktop. Random DWG files is the one folder I have here in my desktop. And these are DWG files I have there. I could use, instead of DWG, like image files or PDF or so on, right? So with one basic, like, there we go. That's it. So now we've loaded a 2D plan into our software. How to use it? We need to make it visible. It is there, but it's hidden. And that's pretty much it. We've loaded the plan of a building and we can work over that. Then we have all these tools to model the elements of a building, to explicitly model the spaces. That's easy. We just need to define them and put a name to them and so on. And once we've done that, we hit the analysis tool so that the edges and adjacencies information, thermal breaks or not, facades or internal partitions, all that information is generated automatically, right? So let's actually do a quick example and move on to a pre-built project, right? External wall. We have nothing there. We need to define a new type. So facade 1, let's say, thickness, and so on, accept. So see that now we have tools. We can adjust the model to the edges, to one side or to the other. We have not only this as an image factor, but we can activate the snapping of the DWG. So we are not only watching the image in 2D, but actually using it as a template, right? So I can quickly generate the exterior element of a building, the facade, right? And that's it. See that we are working floor by floor, but at the same time that I'm working here, I am able to see the 3D. I'm here. So this is what I have modeled so far, right? It's not a 2D thing, it's an actual 3D. Same happened with the slabs, for example. Slab on ground. If I make a mistake, I just may go undo the last enter point and go back into, I'm snapping there. I'm having these tools activated. And again, I may watch what I've just done. Right? Same way I could do a window there. Window 1 with these sizes. And we have modeled a window in a small building, right? There it is. I know this is really simple, but my goal here is to show you what we can do with the program, not to impress you, right? So roof 1. So this way I'm actually fast in the modeling. Okay, I'm in the wrong. Remember, I'm in the level 0. Let's move to the level of the roof, right? To actually be able to watch, I should see, activate the visibility of the floor that's below, and now I can snap and easily model the roof, right? And now I'm actually having like a small 1-floor ridiculous building, and I can add a door, of course, and so on. See that I don't have the door option because in that level I didn't have any wall. door one. We could have different kinds of door. That's the reason I put door one. We could have a door for the entrance, a door for the inner rooms, right? And so on. So let's go there and see what we have so far, right? Well, we have a small door, like a window, and so on. So basically, this is it. We could model the internal partitions by using the internal partition like button there, and so on and so forth. Once we've modeled actual spaces, we just need to hit new space there, space one, for example, and now you would define, you have a space there. It's as easy as that, right? And then just run analysis and you have a BIM model with the information of surfaces and adjacencies. So we've gone from 2D to BIM really fast, actually. To move this model out of here and into the BIM Service Center, we simply need to use these tools over there. The update is to select a project and connect to that. If we want to, we could download things from the projects here. We're not interested in that yet. And after connecting to the project with the update button, once we are connected, we just need to share. We're sending this model, we're sending this, we're seeing here into the BIM Server Center platform, right? BIM Server.center. So we would send it, we would be sending it there, right? That's the way we just work. It's easy to use. So same way we just done this ridiculous small building, we could define this example that we have for with the program, which is a school center. Again, a really simplified version of that. And the purpose of this is to use the SciTherm loads program to get the loads of this building, right? See that what we can get from the IFC builder is more geometrically limited that what we can achieve with Cyber architecture or Revit, for example. But the good part of it is that we have the adjacencies and edges information already there. So this is what we may expect. What we're seeing here on screen is what we may expect to achieve with the IFC builder, right? We have users that actually have achieved really complex models. But if we actually have a model that it's not meant to be regular and so on, we could use Cyber architecture. This is what we could achieve with Cyber architecture. Or we could use any other BIM modeler. Remember, if we are using if we are not using IFC Builder, we will have to actually use OpenBIM analytical model to do this that we don't have, the edges and adjacencies, right? That's what we use the IFC Builder. So this is the IFC Builder example of one school center. What I'm going to do is open that same building from the SciTherm loads, right? So once I'm going to actually open the program from scratch so that you see how to use it. Maybe it takes a few seconds to open. It is a powerful, it has many databases there. Okay, so this is SciTherm loads, right? When we open a new file from scratch, we should log in into the BIM Server Center. The program asks me a security check there. I will allow from my account to the program to get connected. Accept. So now I am connected there. Then I have to select a project. Let's say, see if I have one of these. Yeah, MEP Hackathon, for example. Let's see what I have there. Yeah, school center. So I have uploaded from the IFC Builder into the BIM Server Center, and now I'm reading that from the SciPy loads. And that's pretty much it. Okay, so now we have imported the building into SciPy loads. This is the look of the program. Do not get scared by the fact that we have a lot of errors. Actually, this is good news. This is the program telling us you have done nothing so far with that element. So you just need to do something with the element. This way you're not missing anything, right? So let's explain how to use SciPy loads. We have two parts in the project tree of information, right? We have the libraries. It's like the type definition part of the program, and then we have the project, the actual elements that are part of our building, right? With their spaces and so on. Well, the ones that are in the model, right? So what we need to do here is to define types of spaces. Let's say we could have this empty. In this case, we have defined the types in the IFC builder, but we could do it from here, right? A new type, and that's it. And then go edit that element and define the design conditions, right? So the design conditions of a space are the ones that will really affect how much power will that space consume, right? So if it's non-habitable, it won't consume any power, possibly, right? So end of the story, or really little. But if it's habitable, it will depend if it's heated or cooled, only heated, and so on. So if it's only cooled, possibly it will use power in summer because you're only cooling that place, for example, right? Or if it's only heated, it will only be using power on winter. If we do both, we're going to keep one specific designed conditions for that room along the year, right? If we're going to cool, we need to achieve that temperature, for example. We can modify that data there. Or we can, if we're going to heat, we need to achieve this, right? So this gap will be the one that will define if we're going to be ambitious in the consumption, if we're going to be, if we want comfort, if we're going to decide comfort over sustainability, what is the minimums? Is this a workplace? Then we need to guarantee specific conditions there and so on, right? So this is the first things we need to choose. And then we have the gains and losses of heat that are produced by different situations. For example, the ventilation will produce the fact that air leaves the room and gets into the room. So that will mean that in summer, possibly we're going to allow heat into the room, and in winter, we're going to allow cold into the room or heat to get lost, right? So here we can define what is going to be the ventilation. All this comes from ASRIA's method, right? From the Radiant Time Series method, that we have a European equivalent. But basically, this used to be ourselves opening a book, a bunch of tables, and deciding, okay, how much ventilation. So what we do is just simply click the blue arrow and access the official ASRAE database. So we have information there. This is a school, it was a classroom, so let's go with this one. So the ASRAE standard says that, okay, the flow per person is that liters per second, and because we're using that kind of thing, that's it. The program fills that in for us. As easy as that, right? Then we'll have the possibility of defining if we're going to have heat recovery systems or not. What is the thermal efficiency? We can go deep into that, right? And then we can define, okay, is this room going to be used all the time or not? Maybe it's going to be, this is a school, for example, so we could not use it in summer, at least it's in the North Hemisphere, right? So July and August, 0% use. So we're not using power there. And maybe, okay, we could go, this is a school, this is not 24/7 open, it's only open like half of the time. So we could just define a percentage, right? Or we can go deeper and say, okay, this is a classroom specifically. So we can define a profile with the name classroom 1 and say, where is it going to be used? Okay, so maybe the kids arrive at the school like 7 a.m. and leave 3 p.m., right? The hours of schools are different from one country to another. Maybe there's a break here. Maybe you leave at 5 p.m. Maybe you leave 2. I don't know, right? But you can define that and accept. So we are precisely defining what is going to be the use, right? So we have the tools there for doing that. Same happened with internal heat gains, for example, that are due to the occupancy, like the heat that the humans emit when we are in a closed environment. Equipment in a kitchen, for example, we have machines or things that emit heat, that they generate heat, lighting too, and different loads that we can define missionally. So as easy as that, what we need to do is define the design conditions of a space. See that this red cross is no longer there, right? And once we define a classroom, we just need to go to this is the types area, right? Just need to go to the project, grab this room. When we click, see that we're moving around there, and we need to tell the program, okay, this element is the type classroom, right? We just need to look for it. This comes from there. Just pick the right one for each space, and that's it. That's the way we assign elements one by one. I'm moving to the actual example that I have previously prepared so that we're going to save time and in the explanation of this project, right? So same way we have the classroom, we may have a library, a kitchen, an office, right? And maybe we're using ventilation, maybe not. Maybe we have equipment, maybe not, right? Maybe it's heated and cooled, maybe it's only cooled. These are the design conditions of the spaces. So you see that we don't have a red cross here because it has been designed. We don't have the elements, right? We have this element, which is the slab on ground. The floor 1, which is the intermediate floor slab, and the roof, which is the roof slab, right? Then we have partition elements, the facade in this case, and partition elements in there, right? So what do we do with this program? We define the types, first of all, and then we can go define what is that element like, right? In this case, just grab the slab and say, okay, this is a slab on ground. It's not like a roof. Then if it's a slab on ground, we can define by layers. And in this case, it's just a bunch of concrete, right? This is a really simple example, and that's it. So the way to define it, it was like, okay, add a new layer, grab the materials there, and look for, let's say we access different databases, concrete, and that's it. It's not like I have to remember what is the conductivity or the thermal resistance of the concrete. And it's not like I have to go reach a book or a spreadsheet to do it. I just need to select it from a database, from a professional one, and that's it. I could define by layers with many layers, or chamber, for example, whatever, or cavity, or one insulation, like one layer for insulation and so on, and the program will put them all together. Or we could use a simplified input, just tell the program, okay, I have the data, this is the thickness, this is the thermal resistance, this is the density, the U, the heat coefficients, and that's it. So we could do either way, or we can even go into load manufacturer catalogs, right? So this is specifically this button over there, reach for the catalogs. And we have actual prefab like solutions, like a specific, let's say, attic facades, one wall that's bricks plus air chamber plus insulation from this brand plus stucco. For example, we can just load all of them like from there. So we can be really fast defining the slab on grounds, like the walls. In this case, this was defined that way. Just defined representative wall types according to ASHRAE. So this was coding wall with this definition, that properties. We just click that and we have it. We don't actually need to go layer by layer defining the materials, but we could do so if we have the data from our manufacturers. If we have our project, have the information on the walls, we can define it. And we can go define the partitions the same way. It's just bricks with an air chamber, it's just bricks with an insulation, whatever, right? Define, is it a partition wall? Then layers, simplified input, prefab solution. Same happened with the roofs, right? So we've defined spaces, elements, which elements would be roofs, slabs, walls, and so on. We can go into defining doors, right? With the heat coefficient, the absorptance, and so on. The windows, same. We can even go deep into the definition of the shading, for example. This comes from the ASHRAE methods, professional methods worldwide accepted. So we can even go into the definition of the shading, if it's glazed, if it's, again, if you have a specific manufacturer solution, you can use it and go define the windows and so on. So once you define what will be the design conditions of the spaces and what is the elements that are forming the building, what is the wall, what is the roof, and so on, we just go there into the linear thermal bridges, right? You don't have to go define the coefficient for each of the edges of the building. You just need to click there, edges processing, and you're going to be processing all the edges according. You can configure, you can go deep into it, and it tells you according to what, right? So this is the code that you're going to be using. It can go even into the definition of different situations, like slab on ground, raised floor slab, balcony, roof. So this is the way that it encounters. The small graphs there are explaining what is each of the edges. So you can even go and really go precisely defining it. But you can just trust the standard and hit accept. And you get all these automatically feed for you. So here we have just saved maybe 2 days of work, like maybe 16 or 20 hours. So just that way, again, we've saved a lot of time just using the database that are within the program instead of manually just checking the books. So we've saved a lot of time. With a bit of practice, you're just defining the spaces really easily. And once you have everything, you just need to check that the spaces are correctly defined, right? So you can click them, watch them here. Okay, this is the classroom I have, and I have to check if it's okay, this is the classroom. If it's wrong, you just need to move it into, okay, this is an office, and that's it, right? Just double check. So far, this is what we've done with the Cyptham loads. So we are going, once we've defined the building, which is actual true work we need to do to analyze the behavior of the elements of the building in terms of energy, heat gains and losses, and ventilation and so on, you move to the analysis, right? So we've defined the thermal model, just move to the analysis part of it. First thing we need to do, of course, define the location data. The weather data for the place where it will be. So we are not, if we are in the Norway, it will be harder to heat a room than if we are in the Philippines, right? The room is already hot. So it's so the fact where we are is really important. So we can manually introduce this information if we have the data from our own sources, right? I can modify this and just write all this manually, or we can just import from ASRAI or from SIPE's own database, which is actually limited to the place where we are really popular, right? So we have the ASRAI database there. We just need to go select any place, the place, the continent, the the country, the city, and so on. And according to what we choose, we have all these automatically filled up for you. Once you have it filled, again, you can modify it if you don't like it, right? Okay, I know that it's hotter here in this year, whatever. You can go define your own, right? So first of all, definition of the location. Then the choice of which is the method. The most popular one worldwide is the ASRAI, but in some places in Europe, they're required to use this one, the European one, or it was, if I'm not mistaken, it was a German DIN thing. Then it's being adapted. You just need to choose the method you're going to use, right? After selecting location and the method of calculation, you can go into the zoning hypothesis, right? The program explains you what is the method and what are the calculations, where do they come from, right? And you can have different hypotheses. What does this mean? If I'm talking about a school, I could have the analysis performed floor by floor, for example, or I could have them classroom by classroom. Or I could have different zones of use. In this case, we picked classrooms, cafeteria, coffee, right? Offices, and the areas that are not conditioned. We could do our own hypothesis, right? So to generate an hypothesis is just add a name to it. And then I'm doing an example here. Hypothesis 2, for example, and I actually start saying, okay, the zone 1 will be what? Maybe all the ground floor will be the zone 1, or just the ground floor, but without the corridors. So this is the way we define the zoning. The zoning will mean how am I going to get the data? I'm going to get the data for this room, for the whole floor. The reports will be performed accordingly, right? So I'm leaving the original design conditions there, and that's it. We have it. So we've just defined the building, defined the location, defined the calculation method, and we defined the zoning hypothesis. Now we just simply need to hit the calculator button over there. And that's it. We have analyzed the project. In this case, it was fast. It's a small project, right? So we could have the complete set of reports. This will take a few seconds there, and we can have all the bunch of reports all together in one document. This will be possibly hundreds of pages. Or we could go zone by zone, getting the report per zone, right? So in this case, see that we're generating lots of pages of information, but let's see what we get out of this. Basically, the calculation of the thermal loads and the performance of the elements zone by zone. So actually, we're going with the summary cooling loads for the classrooms. We grab one classroom and start OK. Basically, this is the total cooling load for that classroom, right? Basically, this is the end of the story. But along the way, you have relevant information on why this number it is what it is. So okay, we have this ventilation causing this ventilation causing this energy consumption. We have solar gains. This means we have crystal windows, whatever, of conductions. This means we are having. So this breakdown on the consumption of power, apart from the surface itself of the area, right, will tell us where are we performing well or wrong. So maybe if I'm having too much solar heat gains, I should improve the behavior of that window or put just less windows or remove the windows. Well, I don't know, right? If my walls are losing too much heat, maybe I just put more insulation or thicker walls, whatever. So it's not like I have the final data. It's I have the information to improve my project, and this is what sustainability is about. It's not like just automatically, magically, some IA defining what should my wall be. It's okay. We make decisions. We have the results with the choices that we made, and now we need to decide, okay, am I going to remove the windows, put more windows, or am I going to improve the walls? I could do both, do either, just put a super efficient wall and forget about the windows. So the decisions are infinite, and they're up to one professional to make, right? This is a small example on maybe checking out what we have. We have, of course, a breakdown of each of the calculation. This is 100 pages there. Actually, having the graphs per classroom, per zone. If it was a housing project, it would be like a house per house, room by room, right? Overview calculations. So we have the graphs there. And not only that, we also have the reports about the materials, the description,